Question number 1. What's a model?
A replica of something? Yeah, maybe a smaller size.
Yeah.
Plus, most humans are humans in general are very visual. So if we have something we can touch and feel in front of us, it's much better than just looking at a piece of paper with a bunch of lines on it and numbers and try and imagine like what it would look like.
Is a picture of something a model of something?
I guess.
If a model is a recreation, then yeah. It's just a representation of something in another form, generally for convenience purposes. To make it easier to see something that's too small, to make it easier to see something that's too big.
So you're trying to take something that you can't put in the room and see. You're trying to make it so you can put it in the room and see it, either by blowing it up or making it smaller or...
Yeah.
So a model could be on the computer. It could be something big that you've shrunk down. It could be a math equation or formula. You were mentioning formulas. Wow, model could be pretty much anything.
Jim uses the Modeling the Universe activity not only to assess his students' astronomy knowledge, but also to reflect on the nature of scientific models.
Dark matter is a black hole.
Well, isn't dark matter what's inside of a black hole? Or is dark matter just whatever's in space?
I haven't read that chapter yet. I don't know.
Ain't dark matter? The 4 first planets are pretty close together, and then there's kind of a gap between them and like Jupiter and Saturn, and then there's a lot more of a gap between, well, the last 5, I guess.
Farther and farther apart.
Yeah.
So Pluto should be like all the way out there in the hole. You know, we can do what we can do.
We got space.
You want us to go put Pluto in the hole?
It's up to you.
All right, Dan, you're all...
We're just on the table. We don't have to... No, you have the planets roughly the same order as the other model. And your distances are almost 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units. Your model, Dan, there was a little bit different in the distances. You had a big distance between the Sun and Mercury, and then the first 4 were kind of close together. Was that intentional, or?
Well, yeah. As compared to the last 5, the first 4 are closer together.
Okay, but so this model is showing them all relatively the same.
But I mean, the model just shows a different thing. Like for a kindergarten class, if you just wanted to teach the order of the planets and like how they move around the sun, like that'd be fine. Like they don't necessarily need to know like spatial relations and stuff. Yeah.
Many students who construct the textbook solar system model think of it primarily as an illustration, a schematic diagram of the real thing. But a good scientific model makes predictions about real phenomena.
Using this model, could I see Venus at midnight?
What?
Using this model, on the Earth, could I see Venus at midnight?
Like you were standing here at midnight and you were looking at the model.
You'd be
I'm outside, it's midnight. Could I see Venus? Boy, I don't know if I could see Venus. I better take out my model and I want to see if I could see Venus.
No, because you're on the opposite side of the sun. I mean the
Spatial
Earth.
relations aren't correct. Like you need something to like, you need to be able to like see something and like, okay, according to this, like Venus is going to be such and such a place to like this distance to the right, this distance up, and like you just wouldn't get that from a 2D model, like regardless of how amazing it is.
Let me make my question more open. Using this model, is it possible for someone on the Earth to see Venus at midnight?
Well, no, because isn't Venus closer to the sun? And like at midnight, you're facing away from the sun, basically.
So this model is helping you make predictions.
Oh, okay.
This model is saying, and your model also, if this model is correct in that facet, if I'm on the Earth at midnight, facing away from the sun, there's no way I can see Venus. What facts did you not have that you wish you had?
You need quantitative data,
Like what?
like about the size of planets and like how far they are in relation to each other or to the sun.
Why would you want that information?
Because then you could, from that information, you can make your own scale of how you could turn like the miles into inches or whatever you wanted to do and make more accurate representation of what it is.
And more accurate in distance out and in,
Right.
in size.
Correct.
Right. One of the problems is that every astronomical drawing you've seen is hopelessly out of scale. Every single one, I'm going to bet. It's hard, if you're talking about the sizes and then to also show the distance from the sun, it's very hard to do both of those at the same time accurately. Let me show you a different model.
The Earth's that big compared to the sun.
Okay, so Earth is too big.
Earth is way too big.
Yeah, way too big.
Scale's
So is the moon.
This distance has no relationship to that distance.
No, not really.
That distance has no relationship to that distance.
Exactly.
That is nowhere near that. Okay. But what's it help you do?
Watch the rotation of the Earth as it goes around the sun.
Without any planets to get in the way.
Okay.
And you can see like what time when it's daylight.
How many days does it take the Earth to go around the sun?
365 and a fourth.
How about according to my model?
About 30 seconds.
So you would assume that as the Earth's going around, by the time it goes one full rotation around the sun, that the moon has gone 12 rotations around
No, but
the Earth.
The Earth is spinning past too, so it might be accurate. It actually is probably accurate.
So not only is distance out of scale, time is out of scale. So it's wonderful on a lot of things. It is showing eclipses.
Shows the seasons too.
Shows the seasons. But it doesn't show time, it doesn't show distance. It's just focusing on one little thing, right? Any model is going to have inaccuracies. And you got to be upfront about those inaccuracies. This simulation, this model is really good for this, but crappy for that, right? This doesn't show any of the other planets. So we all got the Earth, and there's a reality. But you can make a model to show whatever one thing you want.